Okay, in this short video we're just going to show a number of different ways to compile a single source file. Last time we looked at figure A1, a very simple C++ program. Let's take a look at how we might compile that program. The simplest way is to simply type G++ and the name of that program. Oops, I guess we're not there. Let's go into the source folder, review, and figure. Okay, so it's going to be figure A1. Let's try that again. G++ figure A-1. And that alone, no message is a good message here, indicates that we've created an executable. And if we take a look here on a Linux file system, the program that's created automatically will be called A.out. On Macintosh, it'll be called A.out. On a Windows-based machine, particularly if you're using Cygwin or some MinGW installation of G++, it'll create an A.exe file. At any rate, we can run that really easily by just typing period / and then the name of the executable. In this case, it would be A.out. And we're asked to enter a sphere, and the volume is, there you go. Now it's probably a good idea to verify that the calculation is correct. Alright, so if we look again, it should be 4 pi radius times radius divided by 3. So that should be 4/3 pi, right, because radius was just entered in as 1. And so if we were to run a calculator program, and did 4 divided by 3 times, do we have pi? I guess we have pi there. Should be 4.18 blah 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 blah. And we look here and we've got 4.18 blah 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 blah. Looks good. We could run it one more time with a different value and make sure it's still working good. Do something different, like 2.5. So now, what do we have? We have 4/3 pi times 2.5 squared. So if I check that result, whoops, if I check that result, I should get the same thing. 4 divided by 3 times pi times 2.5 times 2.5 gives me 26.17, and we're good. So I'm pretty confident that the calculation is working correctly. Now, there's some other ways we can compile this. Sometimes we're going to make use of C++11 standard conventions and syntax and whatnot, so we'll have to tell G++ that we're doing that. So we can do that with a switch that goes -std equals C++11. Make that window a little wider here. And, oops, we need a source file. And again, without naming the executable, this will just create, in this case, overwrite the A.out file. And so here we've told G++ to use the C++11 conventions and standards. Now, if we want to name our executable, we can do so with a -o and say call it figure A1. And notice it's different here. What follows the -o is the name of the executable we're going to create. And the final argument in G++ here is the source file itself. Alright, so don't confuse the two. And now we have a new file called figure A-1. And again, on Linux there won't be an extension if we don't provide one when we named it. On Windows it would probably be called figure A1.exe, and we would run it the same way. And it's the same program. Okay. Finally, we could also name it and also stipulate that we're using a particular flavor of Linux, a particular flavor of C++, In this case, no rhyme or reason. I'm just showing you that there are other values available for this. We could use the C++ 17 standards in compiling it. And again, this has created an executable called fig.a1, compiled against C++ 17, and the source file that was compiled was fig.a1.cpp. I'm just going to remove fig.a1, and life is good. So there you go. There's a couple of different ways to compile just a single source file using G++.